Ever wondered why volcanoes, these majestic mountains, suddenly decide to blow their tops off? These fiery giants are an enigma, shrouded in mystery and unpredictability. Volcanoes are more than just mountains. They're a testament to the Earth's power, capable of creating and destroying in equal measure. Their eruptions can be as beautiful as they are devastating, a spectacle of nature's raw force. To understand this explosive behavior, we need to dig deeper into the Earth's structure and the science of volcanoes. Beneath our feet is a world of hot flowing rock, divided into layers. Now, let's take a minute to understand these layers. The outermost layer, the one we live on, is known as the crust. It's like the skin of an apple, thin and brittle, covering the whole Earth. Beneath the crust we have the mantle, which is like the apple's flesh, taking up most of the Earth's volume. It's a hot, semi-solid layer of rock, constantly moving and flowing. Now at the very center of our planet we find the core. Picture it as the apple's seed composed of molten iron and nickel generating the Earth's magnetic field. Let's circle back to the crust. It's not one solid piece, but a jigsaw puzzle of large sections called tectonic plates. These plates move and interact, driven by the heat and pressure from below. When these plates interact in certain ways, a special, often explosive guest makes an appearance, a volcano. Imagine a pressure cooker, sealed tight, heat increasing. What happens when the pressure becomes too much? The same principle applies to the birth of a volcano. Our Earth, in its incredible complexity, is like a giant pressure cooker. Deep beneath the Earth's crust, intense heat and pressure work together to melt rocks, creating a thick, molten substance called magma. This magma, due to its lower density, naturally wants to rise, pushing against the Earth's crust, much like the steam in a pressure cooker pushes against the lid. As the pressure builds, the magma searches for weak points in the crust where it can escape. These weak points, often found along tectonic plate boundaries, serve as the perfect exit routes. And then, with an explosive release of energy, the magma bursts through the Earth's crust. The molten rock, now called lava, flows out onto the Earth's surface. The magma forces its way out, and thus, a volcano is born. Not all volcanoes are alike, and neither are their temper tantrums. Indeed, the variety in volcanic activity is as vast as the landscapes they shape. Let's dive into the three main types of volcanoes: shield, composite, and cinder cone. First, meet the shield volcano, named for its broad, shield-like shape. These gentle giants are the product of effusive eruptions, where lava oozes out slowly and steadily. The result? Wide, sloping landscapes like those seen in Hawaii. Next, we have composite or stratovolcanoes. These are the classic cone-shaped volcanoes we often imagine. They're formed from a mix of explosive and effusive eruptions, creating layers of ash and lava. Mount Fuji in Japan and Mount St. Helens in the USA are prime examples of composite volcanoes. Finally, let's talk about cinder cone volcanoes. These are the smallest and simplest of the bunch. They're built from particles and blobs of congealed lava ejected from a single vent. These eruptions are usually pretty explosive, like a fireworks show by Mother Nature herself. Of course, eruption styles vary too. We've touched on effusive and explosive eruptions, but it's worth noting the extremes. Effusive eruptions are like a slow, steady exhale, producing rivers of lava. Explosive eruptions, on the other hand, are like a violent sneeze, sending ash and debris high into the sky. Whether it's a slow lava flow or a dramatic explosive eruption, each volcano has its unique way of venting out its fiery rage. Volcanoes, as we've seen, are a fascinating and complex result of the Earth's internal activities. They are not merely mountains spewing fire and brimstone, but are intricate geological phenomena that speak volumes about the inner workings of our planet. The stage for these fiery spectacles is set by the Earth's crust, a thin layer on the surface of our planet, beneath which lies a hot, molten mantle. The birth of a volcano is a testament to the dynamic nature of Earth. It is a process that begins deep within the Earth, where heat and pressure cause rocks to melt into magma. This magma, under immense pressure, forces its way through the Earth's crust, resulting in a volcanic eruption. The various types of volcanoes, be they shield, cinder cone, or composite, and the nature of their eruptions, whether explosive or effusive, further add to the diversity of this geological marvel. Next time you see a volcano, whether in person or in a picture, remember the incredible forces at work beneath its surface.